Okay, so we're on lesson 4B, polynomial functions and rates of change. So we're still talking about concavity, and we're introducing the word points of inflection, okay? So up first, you have a function f is concave up. So we're going to write is concave up on an open interval if the graph looks like a U. So that's kind of the way to remember. If it looks like a U, then it is concave up. Agree? Okay, a function f is concave down on an open interval of a graph if it's an upside down U. Okay, so I'm going to go over here and I'm going to highlight those pieces. So I'm going to highlight in green where it's concave up. So in green, I'm concaved up. And I'm going to highlight in blue where I am concaved down. Do you notice that I did not go all the way up? Yes? Okay. The reason why I didn't go all the way up is that point where they meet, this piece right here, that's called a point of inflection. Has a point of inflection, not inflection, inflection at C. So at some point right here, that's where you change from being concave up to being concave down, okay? Where you go from being a U to being a upside down U. To find your point of inflection, I call it my PI. Your PI equals the average between your max and your min values. The average of max and min values. Okay. Now, when I say values, remember that means I'm referring to the y's. So could I find the PI here? Could I find what C is for this problem? Yes, because in this case, our C is going to equal the average between our max and our min. In order to find the max, we add and we divide by the number that we have, right? So we have -6 plus 4 divided by 2. And that's going to give us, what's -6 plus 4? -2. -2 over 2 is -1. So we know that the y value there is going to be -1. So this equals our y of our PI. Okay. Now, I also need to find the x, so we also have to do it again. I don't know why I emphasize y values here, but we got to do both. So to find our x, it's going to be -2 plus 3 divided by 2. What's -2 plus 3? 1. 1 divided by 2 is just a half, and fractions are our friends. So is there any reason to change it? So our PI is at 1/2 -1. That's our PI. How do you feel about finding a PI? The same way you found the y? Okay, so on example number 7, I would like for you to identify our point of inflections. Why do I say it as a plural? That's because how many times do I change the direction from being concave up to being concave down? I change it twice. So we have how many PIs? 2. We're going to have 2 PIs for this problem. Key thing to remember is that your PIs, your point of inflection, that is not how you spell inflection at all. I have no clue what I was spelling right there. called I need sleep, equals your turning points minus 1. Turning points minus 1. So last week we talked about turning points. Turning points are how many times you go from increasing to decreasing that situation, right? And so I have 1, 2, 3 turning points. So there are 3 turning points. So therefore, I'm going to have how many inflections? 2 points of inflection. I'm going to be warning y'all, I start getting lazy. This is called TP, and these are called PIs. Toilet paper and private investigators. All right. Can you find them? Yeah. All right, go for it. 90 seconds. Find my 2 PIs. Wait, I said wrong. I said wrong. All right. Let's talk about it. So first thing it says, label approximate locations of each point on the graph. So that was step 1. It's label approximate locations. So I'm going to say approximately, here's one turning point. Here's another turning point. Here's another turning point, correct? So if I give them approximate values, I'm going to give this one, looks like it's at negative 2.1 comma negative 6. That's an estimation. This looks like it's at 1.1 comma 1.1. That's an estimation, approximation. Then I'm going to this one's pretty, I'm going to say it's 3.0. That's all I asked of you. Then we're going to find those PIs. So the PI from here to here is the average between my X's and my Y's. Make sense? So to find my approximate first PI, I'm going to just do it in one little swoop. So my first PI equals, and I have negative 2.1 plus 1.1 divided by 2, comma, negative 6 plus 1.1 divided by 2. That's all it's asking you to do, is to find the average between the points. Now, I only have 2 of them, so average means I divide by 2. So I get negative 2.1 plus 1.1 gives me, if you said negative 1, thank you very much. No one said it, so I'm just going to say negative 1 divided by 2. Next one, negative 6 plus 1.1. Negative 6 plus 1.1 gives me, you got what? It should be 4.9, right? If you owe me $6 and you give me $1.10, you still owe me $4.09, right? So that's negative 4.9 over 2, which will give you some sort of value of 2 and some change, which is roughly where this is located. Does that feel like a fair assessment of where that is? Yes.
This is on a test. How are we supposed to know if our answer is right or wrong if there are no exact points?
1, on the test, you'll probably have an exact point, and 2, it would be a multiple choice. So through deductive reasoning, I would say you would be able to identify. Like it wouldn't be, yeah. This is just, can we approximate? Can we identify? Oh. All right, on here, again, all we're doing mathematically is adding and dividing. So we have 1.1 plus 3 divided by 2. Then we have 1.1 plus 0 divided by 2. If you have $1.10 and you add $3, you now have what? $4.10. And if you share that between your sibling, you each get how much? $2.05. So 2.05. Does that seem like a good estimation? Pretty decent. All right, 1.1 plus 0 is 1.1. You now have $1.10, and you're going to share that with your friend. How much do each one of you get? 55 cents. So that's 0.55. Does that feel like a pretty fair assessment of where this is? Yes. Can you approximate? If you can approximate, then you can do it with the exact. Okay. Questions about turning points and points of inflections. If it seemed hard, did this help clarify? It did? All right. The key thing here is that it's about the vocabulary, not the math. Got it? Vocabulary, not the math. Anthony, please put it away. All right, so this is tying your prior knowledge and current knowledge all together. So here we have function g of x shown at the right on the graph, and then its values are also on the table. From there, at this point in your life, I'm not going up there. Someone close the door. You're gonna have to identify the domain, the range, the type of function it is, meaning is it a positive or negative, odd or negative, odd, or even degree function. Okay, there's zeros and their multiplicities. Keyword here, multiplicities, bringing back that word.
And having a it's better to see.
What are you gonna do to me? All right, multiplicity. So, do y'all remember me saying to kiss the line, touch the line, to do the drive-by? Does any of that ring a bell? Okay, your multiplicity. So your multiplicity is describing how is your function behaving around the x-intercept, okay? So what is it doing around its x-intercept? So we're gonna do that one together, just bring back. This right here is a single multiplicity because it just crosses the x-axis. Does that make sense? So we have a 0 at x equal -5, and it's a single multiplicity because it just crosses. Yeah, I have a thing to do. All right, so here at -2, at -2, we also have a 0, agree? At x equals -2, but it has a double multiplicity. Okay, that's because it kisses the line, it touches the line. It doesn't cross it, it touches, it kisses the line. Any of this ringing a bell from polynomials with the factors? Nope. Okay, that's cool. Okay, at x equal 2, it's going to be another single. God, I'm just trying to record a video. At 2, it's a single, and that's because it just crosses through. Okay. If it was a triple, it would be that little slow roll drive by. It like slows down its rate. That's better. The other one was questionable. Ignore that line. So it'd be like it curves through, it slows down, and then zooms off. I mean, probably not the best description to call it a drive-by, but that's how I remember triple is a functional drive-by. Okay. It works for me. Like you go slow down, then you zoom off, right? One other time they do that.
Be a hit or run.
Okay. You know, I don't know. That's where I went. All right. But everything else you should be able to do, correct? All right, so I'm going to give you 2 minutes. State the domain, the range, identify the type of function. Huh? Well, your domain is, yes. And then go from there. And then you have the relative maximum, relative minimum, absolute maximum, absolute minimum, if it exists. No, you're doing it. Yeah. And then you're going through how many points of inflection. I didn't say find them. And just tell me how many there are and why. And then where is it concaved up and concave down? That's where you're going to have to tell me my PI, right? You can't tell me where it's concaved up and concave down without telling me the point of inflection. Got it? Okay. I'm gonna say 3 minutes. 3 minutes to try. Interval. Your domain is in either interval or inequality notation. Your domain? No, it's a continuous function. It's right here. Yeah. This is just a piece of the values, but this is the whole function. All right. Ooh. This is your time to ask me questions. If you. All right, here we go. So the domain. What is my domain, everybody? Really, Jacob? Negative infinity to positive infinity. What's my range? Bottom to top. What's my lowest? It's not quite 8. It's like negative 8.1. If you're gonna be technical. Just saying. It's like not, just saying. No pressure. But if you put negative 8, I'll roll with it. And it goes all the way up to infinity. Oh, that one got bad. Just roll with her. All right, type of function. Is this positive or negative? How do I know it's positive? Your positivity is based off of your right in behavior. So my right side goes on to positive infinity, right? So therefore, this is a positive function. If it was going down to negative infinity, then this would be a negative function, okay? Next, we know that it's a even degree. How do I know it's an even degree function? My in behaviors are doing the same thing, right? We're both waving our arms like we don't care, okay? In the air. So knowing this, what is the degree of my function? It is a 4th degree. Okay. There's 2 ways of knowing it's a 4th degree. Way number 1 is my turning points. I have 3 turning points. Your turning points are going to be your degree minus 1. We see that? Pew, pew, pew. The other way is when I stated my zeros in their multiplicity. So this was 1, 2, 1. How many total zeros did I have? 4. So that also verifies that this is a 4th degree polynomial. Got it? All right, moving on. Interval of increase. Where do I increase? -4 to what? To what? -2. And where else? Perfect. 0.9 to infinity. Remember, this is a way of saying and. The union. I didn't feel like writing the word and. Oh, now I got to write it because y'all are saying it. And. You can write the word and. I didn't want to write it. Okay. You need to write the U or and. All right, intervals of decrease. Where am I decreasing from? Negative infinity to -4 and -2 to 0.9. Okay, how do we do on our intervals of decrease? Good. Can I keep going? All right. Up next, where is our relative maximum at? We have it at, where'd my pen go? Do you see it? Ah, there we go. So we have a relative min what y equals 0 at x equals -2. Min max, sorry. Where's our relative min?
-4.
So we have y equals -4 at x equals, I just want to make sure we all know where it's located. I'm being all as detailed as possible, right? It's my notes, so I know where it's going, where I'm coming from. All right, so that's my relative min. Where else? Anywhere else? What's the other one? My absolute. And where's my absolute? There we go. What about absolute maximum? Okay. I'm going to double check. If it asks you on the test, I think it may ask you, it may include your absolute and your relative together. Does that make sense? So I will double check, but technically your maximum, your absolute is also a relative. It's just, it's the biggest out of the relative. Does that make sense? Yes. As long as you understand the other ways that it could be written, then yes. Okay. All right. How many points of inflection do I have? 2. How do I know I have 2? 2. Perfect. 2 PIs. And why are there 2 PIs? Because we have 3 TPs. Remember, I warned y'all I was going to get lazy on writing. So we got private investigators and toilet paper. All right. In order to answer the last 2, you have to tell me where those PIs are. Because you can't tell me where I'm concave up and concave down without knowing my PIs. So I'm going to stop losing my pen, hopefully. Highlight. So for concaved up, I'm concaved up from here to here. Agree? And then I'm concaved up from here to here. Yes? And then I'm concave down from here to here. So I have 2 concave up intervals and 1 concave down interval. How do we feel about identifying? Pretty good. Perfect. And in order to be able to state it, you're going to have to find your point of inflection, your PI. Okay. So for my first one, I'm going to call this PI P1. My P1 equals what? So we're roughly at, we're going to say -3, -2. I see -3. I don't know about -2, but we'll write it. Okay. And then we're going to call this our second PI, just to make it easier on ourselves. Are we at like a half? -0.5 and -4? Are we in agreement with that?
Wait, what? You got it backwards. Yeah, I think you did. Yeah, concave up is not -3, -2. That's concave down.
I was just stating my PIs.
Oh, I'm sorry.
I didn't. No, it's good. I just needed to find my PI before I could state anything. So we have -3 to -2. Are we okay there? Yeah. That's the point. Okay. Where is my second point of inflection? I say a half to -4. So -0.5 and -4. Is it a fair estimate? All right. Can I now state where I'm concaved up and concave down? Yes, I can. So concave up from where to where? -infinity until -3 and where else? -0.5 to infinity. These same PIs are used for the concave down. And where am I concave down at? In the middle, from -3 to -0.5. This what it means to fully analyze a polynomial. Okay, how do you feel like fully analyzing a polynomial? Is this a doable situation? Yes. If you had any points of confusion, have I addressed them all? Or if not, please let me know. Yes, Max.
All intervals are X.
Which one? Not all intervals describe your x's. Yes. Or
Typically, the interval that increases -2 and 0.
for decreasing? Decreasing was -2 to 0.9. Okay. Good question. Any other points of confusion? Nope. All right. So we're going to talk about the next piece. The next piece is about being able to justify. A lot of times with our free response, when it gets to the justification part, that's where we lose points. Okay. So we're not going to talk about numbers or anything. It's just about simply being able to explain what's happening with the graph using vocabulary. Got it? So here we have a graph of a polynomial, and it has 4 points labeled, 4 key points to this function labeled. And it's asking us, is the rate of change of p of x increasing or decreasing at point A? Okay. And we need to be able to explain why we choose that choice, not with the value, but just simply why we choose that choice. Okay. So we're going to write it as a complete sentence. At point A, what do you think the rate is doing? It's what? It's what? It's not. It's decreasing because the whole thing is concave down. Yes, but it's part of a concave down situation. Because you're talking about the rate of change. You're not talking about what is the function doing. The key thing here is rate of change. Rate of change is we're analyzing that concavity. What is our concavity doing? Okay. So here at point A, the rate, your rate of change, your ROC of, what is this called? P of X is decreasing. Since the graph is concave down. Since the graph is concave down. Okay, it's not saying what is the function doing. We're describing the rate of change. Our rate of change ties into our concavity. Got it? Yes. Vice versa. If I asked you what took place at point D, you're going to tell me what? Why is it increasing? Because it's concaved up. Make sense? All right. Let's go on to B. So it says B. What is the rate of change at point B? Why nothing, Hudson? It's at a turning point. It's at a maximum. So when we look at B, B is at a turning point. So this is a constant, right? That's where we're at 0. Our rate of change is nothing. It's 0. So what is the rate of change for B? At point B, rate of change equals 0. Why does it equal 0? It's a turning point, right? It's a turning point. So a turning point means that it could be a maximum or a minimum. Meaning that we're changing from increasing to decreasing. Is it all that necessary? No, but I just want to make sure we're all on the same page. My ADHD is working overtime. Yeah. Yeah. All right. Tell me, could point C be considered a point of inflection? Why or why not? Point C. Is it considered a point of inflection? Why or why not? We got a yes. We got a no. Anyone else want to chime in? Is point of C considered a point of inflection? Why are we saying yes? There we go. So point C is a possible PI. Why is it a possible PI? Because it changes from concave up to whichever way it went. P of X changes from concave down to concave up. Do we see how this is a vocabulary check? Making sure we understand the vocabulary and where it's applied. Is D positive? We already discussed this. Is it positive or negative? And why is it positive? It's concaved up. Yes. D is positive. Because why? It's concave up. No, you probably want to write rate of change. I mean, yes, in theory, a grader would know. As it gets closer to the test, we're going to look at student sample work from last year, and then you can kind of see where things got deemed. All right, how do we feel? This is our last section of Unit 1A. How do we feel about Unit 1A? Okay, I like the word confident.